let's say we have y is equal to the cube root of x. Let's also say we have y is equal to x over 4. Actually, let me do this one in a different color. Y is equal to x over 4. So before I explain what we're doing, let's just graph these two functions. So graph them to the left here. We have our, let's do that in a different color. We have our y-axis. Having a difficult time drawing today. There we go. We have our y-axis and our x-axis. And so to graph the first one, well, we know the cube root of x looks something like the square root of x, right? It just increases more in the beginning. So from 0 to 1, so it looks something like that. And then x over 4, well, that's just a line that goes through the origin that has some sort of slope, right? So that line should look something like that. And this is not totally accurate, but this will allow us to do what we need to do. All right, now let's say the problem says, determine the volume of this shape rotated around the y-axis. So before we do anything, let's just try to, I think the hardest part for me when I learned this is trying to imagine what it looks like. And I think it's difficult to imagine what it looks like, but if you just draw the first circle that you think will shape, it becomes much easier to visualize. So let's just do that. Well, I'm gonna start here. If I rotate this, I get some sort of circle that has a same radius on both sides, like that. And then also the blue portion makes a circle. And the part that actually has area in this case will be this shaded part. And I'm going to draw more and it'll become easier to visualize, but just keep watching the video for now. So let me draw a couple more circles. Let's draw one here. Again, some sort of radius formed by the line, and then some sort of a radius formed by the cube root function. And again, there's a hole in the middle, and the part that has area is this shaded part. So this might be a little easier to visualize now, but I'm gonna keep going because I remember when I first learned this, visualizing these was very difficult. And it might not be the same for you, but for those that still can't visualize it, I'm with you. All right, we have that one, and then we have again this right here. Let me try to draw these a bit better. And again, this one has an area like that. You can think of them sort of like pineapples. And if we just keep drawing an infinite amount of these thin circles, we get some sort of cone. So actually here, let me draw the last one on top. So it'll help us a bit better. Like something like that. And then, and that was pretty bad, but again, we'll have area here, right? So now if we just keep, drawing an infinite amount of circles, which is obviously not possible, we would notice that this just shapes some sort of cone that has a hole in the middle. And so if we want to find the volume of this, cone, well, maybe I should say what the problem is. So the problem is to find the volume of this cone. So to do that, we need to add up an infinite amount. This should be connected here, so I think you get the point though. We need to add up an infinite amount of these areas that are shaded. So how can we find the area of one of these slices? Well, first we have to notice that the radius of these circles change depending on y. So they change as a function of y, right? So let's find the area of one of these circles. So let's pick this one right here. So this one right here. Let's think about what we can do. Well, if we take the radius of the full of the whole thing, right? So let me draw that with a different color. We'll do red. If we take the radius of the whole thing, which will be from here to here, we can determine that length by this function right here, right? This r length is the distance from the origin, sorry, not the origin, from the y-axis to this line, and it's some length x, right? And x is equal to 4y. So depending on what y value we're at, that gives us the radius. And then if we want to find the radius of the inner circle, we can do something very similar. We can take the length from, again, the y-axis to our blue function. And that right there is this, which is x equals y to the third. And if we want to find the area of the shaded region, we can take the area of the full circle and subtract out the area of the inner circle. So let's do that. The area of the full circle, well, that's just pi 4y squared. The area of the inside circle, that's just pi y to the third squared. So the area of the shaded region, which I'll denote by this little thing right here, area shaded, equals, well, like we said, 16 y squared pi, or pi 16y squared, minus pi y to the sixth. Now, if we want to add an infinite amount of them to get the volume of the whole thing, we can do that with an integral, right? An integral is an infinite amount of areas. Now, let's see where we could stop, though, because it stops at this value y, which we don't know, right? It starts at 0, so our integral has a bound 0 to some value, which we don't know. Let's figure that out. Well, it looks like it stops at the point at which these two functions intersect. So let's figure that point out. Again, this is the dy integral because it changes as a function of y. The radius changes as a function of y, like we said. Let's figure out the point of intersection. Well, we know that they intersect at the point at which x's are equal, right? So we can say 4y is equal to y to the third. So we know that 0, 0 is a point of intersection, like we already determined. And also, let's see, let's factor out, let's divide both sides by y, assuming y is not 0. We can say 4 is equal to y squared, so y is equal to positive 2, plus or minus 2. In this case, we want positive 2. So our bound for the integral is from 0 to 2. And our infinitesimally small areas that we want to find is this right here. It's pi 16y squared minus y to the sixth. So now we have our integral set up. Let's just evaluate the integral. So I'm getting tired of that color. Let's switch it up. So the integral of 16y squared, well, that's just 16y to the third over 3. We're not going to forget the pi. Let me write it a bit better. Minus y to the 7th over 7. And then it's this from 0 to 2. From 0 to 2. So now we just have to evaluate the integral of 2 and we're done. So this is equal to pi times y to the third, that's 2 to the third, right? That's 8. So 8 times 16. Let's see, 16 times 8. 8, 4, 12, 128. So we have 128 over 3 minus, we have y to the 7th, so 2 to the 7th. Okay, let's see. So 2 times 2 times 2, that's 8, 16, 32, 64, and then we need one more, and then 128. So 128 over 7. And I think I'm going to leave the answer like that. So pi times 128 over 3 minus 128 over 7 is the volume of this cone that has some sort of hole in the middle.